All right, now we're going to do inverse trig functions. And I have to be honest, inverse trig functions tend to not be students' favorite topic. And part of that is our fault. It's the way we describe it. It takes a bit more logic, but it really is straightforward. Now, the first thing we do that makes life nice and confusing for you guys is we use two different notations. The book uses a notation, y equals arc sine of x, if and only if the sine of y equals x. This is a perfectly good notation. I don't care for it. I tend to use the notation y is equal to the inverse sine of x, if and only if sine of y equals x. All right. You read this as the angle whose sine is x. And let me show you why I do that. It turns out that these are actually inverse functions. So if I want to undo the function, I do what's called apply. I'll apply the sine to both sides. So I'm going to come in here and I'm going to apply sine to both sides. And when I do that, I get sine of y is equal to, now these are going to undo each other, and I'm left with x. All right, so y is an angle, and so that sine of that angle is my value. All right, now let's look at the inverse trig functions. And I do want you to memorize these along with the domains and ranges. Y is the arc sine of x, if and only if sine of y is x. And you're going to see the symmetry here with all of your trig functions. Let's come in and look at some of the graphs. Once again, you need to memorize these or be able to figure them out. Hint, you're going to have a quiz over these. If I look at the graph of the arc sine, the domain is from -1 to +1, and the range is from -2 to +2. And it is defined at these endpoints. While the arc cosine has a domain of -1 to 1, and its range is from 0 to pi, and it is defined at the endpoints as well. Now, if you look at arctangent, it has these two asymptotes at plus or minus pi over 2. So it has a domain from -infinity to +infinity, and its range is between -pi over 2 and pi over 2. If I look at arc cosecant, this is kind of a cool looking function. The domain is from -infinity to -1, and then from 1 to +infinity. The range is from -pi over 2 up to 0, and you see that's open. And then from 0, again open, up to pi over 2. Now you'll notice these points are included, but of course the 0 here is not. Arc secant is very, very similar. It is has a domain of -infinity to -1, and then 1 to +infinity. The range is from 0 up to pi over 2, and then from pi over 2 to pi. But you'll see that the pi over 2 is not included. It's an asymptote. While arc cotangent has the asymptotes of 0 and pi, and then it has a range from -infinity to +infinity. Now, if you want to do, we will go through in class mapping these from the sine and the cosine and the tangent functions. It's kind of a cool thing to do. We'll do that in class. Now, let's evaluate these inverse trig functions. Suppose I have y equals the inverse sine of 1/2. By definition, y equals the inverse sine of -1/2 when the sine of y is -1/2. Now the trick with these is you have to know your rank, where it's defined. So we're going to look on the interval -pi over 2, pi over 2. All right, and we see that our value here is going to be negative pi over 6. All right, that's when the inverse sine, that's when the sine of negative pi over 2 is negative 1/2. Let's look at the inverse cosine of 0. Now I know that this is true. Y is the inverse cosine of 0 when the cosine of y is equal to 0, and we need to look at our interval 0 to pi. See how important those intervals are going to come to you? So I know by definition cosine of pi over 2 is 0. So my answer is pi over 2, and this is indeed within my interval. Now what about the arctangent of the square root of 3? So let's see, my interval is from negative pi over 2 to pi over 2. And I know that the tangent of y is the square root of 3 when y is what? Well, I know the tangent of pi over 3 is the square root of 3. So the inverse tangent of the square root of 3 is pi over 3. Now to do one like this, you need to use your calculator. Now I'm going to give you a few hints to use your calculator. Put it in radian mode. You should already be in radian mode. And when you do one of these, this is a straightforward calculation. We'll do some in class. I'm going to get 0.305. Round it to 3 decimals. And what I want to point out on this one is do not convert it to a version of pi. Don't convert it to degrees. When you get that answer, you're done. One of the nice things about using your calculator. All right, now give this one a go. And when you're done, turn the tape back on because we've got just a little bit more to do. All right, now let's look at properties of inverse trig functions. I already told you they're inverse functions. All right, so if I apply sine to arcsine, I'm going to get x. Sine of arcsine of x is x, and arcsine of sine of y is equal to y on the defined intervals. Same thing is true with tangent and arctangent, secant and arcsecant, etc. Now, how are we going to solve problems using this? Well, it's actually kind of fun. Let's look at this problem right here. Suppose, and this is awful. Guys, listen, I don't want to grab this by hand. I certainly don't. All right, suppose I want to apply the inverse tangent. I want to solve the inverse tangent of 2x minus 3, and that's got to equal pi over 4. Well, the first thing I'm going to do is apply tangent to both sides. So I'm going to apply tangent to inverse tangent of 2x minus 3. And yes, I want you to write this step down. Tangent of pi over 4. So this becomes 2x minus 3 equals 1. Now I'm assuming you know these, or you have your calculator and you figure them out. Warning, you will not have your calculator on the first quiz. And there will be a part where you have to know the major angles. 0, pi over 2, pi over 4, pi over 6, etc. All right, so now this becomes simple solution. So x is 2. Now what do you do when I give you something like this? Y is equal to the arc sine of x, and I want you to find cosine of y. Well, sometimes you're just going to have to come back down and do, some basic trig like you did in a previous math class. Now, I know y is the inverse sine of x, so I know that the sine of y, and remember, y is an angle here, has to equal x. All right, so if this is my triangle, and it's going to be a unit circle, of course. So if that's 1, and I want the sine of this angle right here to equal x. Remember, sine of my angle theta is equal to opposite over hypotenuse. Now, if I do that using Pythagoras' theorem, clearly this side right here is 1 minus x squared. All right, so I've put it down in my triangle. Now it's just a matter of finding out what is cosine of y. Well, cosine of an angle, and I'm using theta instead of y because I think the y is a little confusing. Cosine of theta is adjacent over hypotenuse. So this becomes the square root of 1 minus x squared over 1, or just the square root of 1 minus x squared. So my answer to this question, okay, is cosine of y is the square root of 1 minus x squared. Done. Let's do another one. Suppose I tell you the secant, y is the inverse secant of the square root of 5 over 2. How do I find tangent? Now this is y. All right, so I know the secant is the square root of 5 divided by 2, so my triangle becomes, there's my hypotenuse, and there's my adjacent. So what is this side right here? What is my last side? Well, it's, let's see, the square root of 5 squared is 2 squared plus my height squared. So this is 5 is 4 plus h squared is 1. So this height is 1. All right. So the tangent of y is opposite over adjacent. So that's 1/2. All right, give these a go. When you're done, turn off the tape, finish your homework. Have a great evening.